Sunspots have been underperforming. Expect major solar flares, coronal mass ejections, and lots more, as well as spectacular imagery of the closest star, as you may have come to expect on the Daily Space Weather. Thanks for tuning in. Congratulations on realizing the channel exists. So checking out the colorized magnetogram, you can see there is a massive intermediate South Pole umbra here on sunspot 2916. Also capable of producing major flares is this northern sunspot. I didn't memorize the number. I have no idea what number it is. It's pretty significant as well. So the radio flux has come down a bit. Let's look at some more spectacular imagery here. The northern hemisphere in 94 angstroms. And this is one of the best wavelengths to see solar flares when we see some, and don't be surprised to see some today. This and 131 are good choices. And we've put together this one here with 193 and 171. It's good at showing the active regions as bright spots and magnetic loops, as well as coronal holes at the same time. There was a coronal mass ejection. It came out of this area down here. It's just recent. We'll get to it. Radio flux at 131, I believe. There's the 1 year chart. 131 solar flux units is the 10.7 centimeter radio flux. There's the Space Weather Enthusiast dashboard. Let's blast through more data. A little bit of earthquake activity here around the Pacific Rim, west coast of the U.S., as well as East Asia. Largest quake of the past 24 was a 5.9 at Japan, I think. Some deep quakes at places like Fiji. The Pacific and Antarctic Ridge area saw a decent-sized quake. Nothing in the 6 magnitude range. Indonesia saw a 5.1. There's that 5.9 at Japan that came in just a few hours ago here on December 26th at 8:26 a.m. Universal, 8:26 Universal Time. And let us know if you felt that 3.9 in Kansas, American viewers. Next, looking at volcanoes here. La Palma has been outgassing, and some strombolian activity has occurred there, a paroxysm. Subanosejima, unknown volcanic ash cloud from Subanosejima. Don't fly over it on your hang glider. Hunga Tonga Hunga Ha'apai. 10,000 foot ash plume from Hunga Tonga Hunga Ha'apai. Go ahead, I dare you to try to say it. Go ahead, I dare you. I dare you. Just do it. Do it. Indulge yourself. Fuego, exploding. That's a 16,000 foot ash plume over Guatemala from Fuego. Sangay, exploding as well. Please don't throw your virgins in the caldera at Sangay. It's producing a 21,000 foot plume of volcanic ash. Revenador exploding, flight level 150 over Ecuador from Revenador. Sabancaya, intermittent emissions of volcanic ash. Not sure on the size of the ash plume from Sabancaya. That's located in Peru. Explosive activity continues at Nevado State Chilean in the form of a 13,000 foot plume of volcanic ash. Don't pole vault the caldera. If you're going through hell, keep going. And visit our website, smashomash.com/smashteam. Free posts coming up throughout the rest of the old year. Today's featured product is Mensa. If you've noticed Earth has been sucking lately, make sure you hold those accountable for Earth's recent suckage. Tell your friends and foes to Mensa. Make Earth not suck again. It's up to you and them. Probably not utterly ineffective bureaucracies. Have you noticed some? Let us know in the comments. What's your favorite utterly ineffective bureaucracy? We'll have to do a year in review video about things like accountability in our quest to Mensa, make Earth not suck again. It's part of the function of these videos, as well as smashomash.org. If you want to read about our mission, head to smashomash.com/forum/mission. You can find all kinds of links on the homepage. Smashomash.org will redirect you to it. Smashomash.com. Also, if you're in the market for a bike, if you're a prepper and you don't have a bike, Look me up, links below the video on that as well. I'll hook you up. I'll tell you what bike to get for whatever your needs are, whether it's racing or prepping or commuting. I'll help you shop, and it won't cost you anything to access my expertise, especially if you buy a bike through me. I'll become your official bike expert. Anyway, welcome to the Neo Renaissance. Hit up smashomash.com for links to the merch and the forum and more. It's magnetic, like this data from the GOES 16 and 17. There are the readings from those spacecraft over the past 3 days. Nothing too exciting going on there. Earth is in a North Pole current sheet. Here's the top view ecliptic plane field plot. The magnetic environment between Earth and Sun, using light polarization to figure out potential field surface source lines, which are displayed here on the screen. It also shows you the location of Lagrange point 5, stereo A, and Lagrange point 4, stereo B. Here's a line of sight view. As solar cycle 25 progresses, we see this large transequatorial coronal hole shown here in green, and the Sun's B field shown here in blue. As the solar polar field reversal process suddenly kicks into overdrive, and we see a sudden uptick in solar activity at the same time. So X-ray flux, sunspots, and field reversals, they all happen at the same time. Here's a view of the coronal holes in 193 angstroms. This time not with the 171 angstroms, but 193 by itself. And let's take a look at sunspots. Here's 1700 angstroms, and you can see the size of those sunspots, several of them larger than the Earth itself. Here's the northern hemisphere. Again, that's capable of producing large sunspots. That's beta gamma class. Down here, this one here has just recently become beta gamma class again. And this one here, 2916, is gigantic, and it is indeed beta gamma class. Don't be surprised to see an M or even an X class flare from one of those groups, especially 2916, as we've stated. Since it was initially beginning to rise, it produced an M class flare before it was even in view of the Earth, so keep an eye on that. And when I say ion, pardon the pun. Likelihood of major flares, very high. Likelihood of coronal mass ejections, nearly 100%. The GOES X-ray flux here over the past 3 days, you can see only C-class intensifications here. Expect to see an M-class flare. These sunspots have been underperforming. And you can see the complexity of their fields here in this right group. And we showed you the colorized magnetogram earlier. Let's not beat a dead horse. No spikes in the proton flux. Don't be surprised to see some, along with HF blackouts and so on, when we get more solar flares, and expect more solar flares. It looks like there were some minor coronal mass ejection strikes here. Some little diffuse bits of stuff going on, like here. These changes in the plasma density and velocity all at the same time look like small filamentary strikes on the Earth geospace were likely. Keep in mind these are measured at Lagrange point 1. More on Lagrange points a little later in the video. And make sure you check our cosmology segment. If you don't check out our cosmology segments, there's a whole playlist for it at youtube.com/smashomash/playlists. So check that out. Over 200 videos in the cosmology segments. Getting back to geomagnetism, the KP index is at 1. If you're new to the channel, the KP index is a measurement of global geomagnetism in a simple 3-hour bar format. Next, Earth geomagnetic moment from space, modeled in nanopascals by the Space Weather Modeling Framework. If you want to read more about what this model is, click on details on the Geospace Magnetosphere Movies page, and it will tell you all the inputs. They're certainly not hiding data. If anybody thinks they're hiding data, they just simply aren't. Although sometimes the data goes down because if certain aspects of the model are not included, it becomes an irrelevant model. You see, if you put garbage in, you're going to get garbage out. So your model cannot contain any garbage data. If you've got a satellite down, for instance, if you can't measure the electron flux, it's pretty hard to guess what the magnetic moment is. Anyway, that's 4 hours of data there. The geospace pressure from Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. This model is different units. This is nanotesla magnetic flux density. The last one was magnetohydrodynamic pressure. Like the last one, this is 4 hours of data. It is based on the same model, more or less, but it's Earth's magnetic moment from the ground. Nothing too exciting going on, no geomagnetic storms. Some mild equatorial magnetic pulses. Here is the solar system view. We always show a 1-week forecast, not because we're frightened of planets, because we want people to have perspective. And Venus is going to be swinging through for a close pass. There should be some great crescent Venus images on the internet if you search. And there's where things will be in 7 days on the new moon. Watch out for those reverse werewolves. They'll sleep well, not eat people, and be productive members of society. Next, the in-the-sky.org chart. This is a star chart. If you're up before dawn, you may see Mars rising ahead of the sun. Let's talk more about Lagrange points. Something's on their way to Lagrange point 2. We'll talk about it in today's cosmology segment, so make sure you check that out. It'll premiere after the daily space weather video. Let's talk about the objects at Lagrange point 5 and Lagrange point 1, stereo A, and the SOHO, which includes the LASCO C2. And again, you can see a bit of a coronal mass ejection starting to happen here. It's pretty much taken its good old time. And when we talk about forecasting coronal mass ejections on the channel, we primarily only do it for this side of the sun, not this side. Although we are capable of forecasting them over there, there's just too much other stuff to do that's more relevant. And since Earth is off in this direction, we figured it's more relevant to forecast these coronal mass ejections than these. That's the reasoning. And the accuracy has been one prediction under 100% for the past year. And one of the ways that we forecast is by looking. Again, don't forget to check out today's cosmology segment. It premieres after the daily space weather. Now, let's see if there are any charging hazards. There don't appear to be any at the moment. We did get into electron flux warning levels. You can see very high levels here on the 1-year chart of the relativistic electron flux. And both the GOES 16 and 17 have now gone into warning territory. This isn't a super high level of electron flux, but it could cause some communication degeneration. So a little bit of a missed forecast here. You can expect this next yellow diamond to be above the green box, which is the forecast. And next we'll show the total electron content forecast in a visual. And we're seeing quite a bit of chaos once again. Major GPS errors expected over Antarctica and North America. I'll let this one play through a second time. Very dense electron flux over places like the Philippines, Southeast Asia, the West Pacific. Really the whole Pacific Ocean. When your GPS has to communicate through a lot of electrons, you can get errors of thousands of miles. I've done it. Next, the ionosphere. We're going to show you the ionogram and the anomalygram for the F layer located at 300 kilometers of altitude, in some ways considered the bridge between Earth and space. There's a lot of vibration going on above your head, especially around the equator at noon most of the time. And here's a visualization of that. This imagery shows vibrational frequency in megahertz, millions of vibrations per second. Only at a 1 megahertz resolution, unfortunately. Here's the anomalygram showing anomaly in megahertz from the 30-day median. There's some jittery data in there, maybe some missing frames or something like that. That can be caused by, guess what? Electron flux. Anyway, here's the latest image from the anomalygram. That's 6:30. That's not right. 6:30? Should be like 13:15. Funky. Anyway, it looks like some slop in the model. There's the ionogram for 13:15 universal time. And when it comes to bonus features, we got them. Here's the ground-based solar observatory at El Teide, Spain. And we're bringing this up to show you some of the most current imagery available on the closest star. Look at all the filaments down here. Some of those appear to have ejected or collapsed. Coronal mass ejection warning is not going down as a result. Certainly solar flare warning, coronal mass ejection warning in effect. Massive sunspots moving right into the earthly zone here. That's the GOES 16 SUVI. Great imagery there. Great wide field of view. We streamed it for 22 hours yesterday on the Twitch channel, twitch.tv/smAsho. How about the latest refresh of the colorized magnetogram and the intensitygram? And let's take a little tour of these umbrae. Yowzers. That one there is alpha class. And this one here is beta gamma class. That is certainly capable of producing M class flares. A bit of a lower latitude spot up there as well. So quite a bit of activity. Here are the fields real quick. Geez. That sunspot is not screwing around. Actually, it is screwing around. It's underperforming. They're all underperforming. And we'll close out with ionized helium, 304 angstroms. Great at showing filamentary eruptions, and expect some to continue. Anyway, once again, thanks for tuning in. Don't forget to click our links. Support the channel with a like, a share. Become a member of the Smash team. Pick up some merch. It's on sale, by the way. Santa forgot. Check out the Redbubble site for details. Congratulations on realizing we exist, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name and news.